I'm Aung Myint Myat, and in this video, I will be demonstrating my convolutional neural network with the CIFAR10 dataset. First, I run the dataset to show you the output later on. Then I import the necessary library. First, I import the necessary library for my code, the TensorFlow for deep learning framework, and then the Kira for high-level API neural network. And then the layer and regularizer for defining the layer and applying the regularization, Webflow for plotting the graph and images, and NumPy for numerical operation, Seaborn for visualization, and then the scalan metric for performance evaluation. And then after that, I load the dataset and the CIFAR10 dataset, which includes 60,000 color images with 32 by 32 pixel in a 10 class with 10 classes with 50,000 training image and 10,000 test image. And then I normalize the pixel value from 0,255 to 0,1 to help training. And then I flatten the label, converting from 2D to 1D array. And then I define the class name in the CIFAR10 dataset, which is these are the class name. And then I print the class name along with the image, along with the respective image. And then I make the data argumentation, which include making the flipping the randomly flip the image horizontally, and then the randomly rotating the image by 10%, and then randomly zoom in and zoom out. Then I build my model. First, I define the weight decay and to auto regularization factor to prevent the overfitting. I use the sequential CNN architecture, and then this is my model design. First, we have the input layer. The input layer include the first convolutional block, which is the input layer. It has the 32 filter or feature detector, and then the dream kernel side. And then we have the padding. I put the same because I want the output side and then the input side to be the same by padding the board. And I use the division ReLU, which convert any negative negative value to 0. And then I use the L2 regularization to reduce the overfitting. And then finally we have the input, which is 32 by 32 image with 3 color channel RGB. And then we reach the batch normalization, which normalize the division from the previous layer, which is the input layer. This helps stabilize the training and speed up the convergence, reduce the internal coverage shift. After that, we reach our hidden layer. This hidden layer includes 32 filter, which is the feature detector, and then the 3x3 kind of size, and then the padding same, and the ReLU division, and then L2 regularization, and then we do the another layer for batch normalization, and then we do the merge pooling 2D, which downsample the feature map by reducing the image width and height by half, and then the retain the this layer retain the most important feature of the image but reduce the computation for the training. And then we have the draw out layer. In this layer, we randomly drop 25% of the neural training to prevent the overfitting and improve generalization. Then finally, after that, we reach our second convolutional block. This is also the hidden layer. In this block, we have the 64 filter, which is more than the first block because this layer, which is more, uh, this layer is needed to capture the richer features than the first block. And then we have the kernel size for 300 episode, same as before, patty, and then the division ReLU and auto regularization. And then we have after that we have the batch normalization layer. And then same as before, we add another hidden layer, which includes 64 filter 3x3 kind of size and padding and with the activation review and auto regularization. And now we add the batch normalization layer. After that, we have the mass pooling 2D. After that, we use the we add the drop layout. In this layout, we will be dropping 35% of the neuron during the training to prevent overfitting, especially as the network is getting deeper. And then we reach our third convolutional block, which is also our hidden layer. In this hidden layer, we have the 128 filter, which is higher than the previous block to capture the complex pattern. And then we have the single spot, the pre-binary kernel size and padding and ReLU activation and L2 localization. And then we have after that we have our patch normalization layer. And then same as before, we have another hidden layer. And then we have the patch normalization. After that, we do the mass pooling 2D. And after that, we add our draw out layer. In this layer, we will be dropping 40% of the neuron during the training to prevent overfitting, as this layer has many parameters. And then we reach our fully connected we reach our fully connected layer. Before that, we need to flatten our data, so we add a flatten layer. This layer flatten 3D feature map from the less convolutional block to 1D further. After that, we reach our dense layer, another hidden layer. This layer have fully connected layer. This layer is a fully connected layer with 250 neurons with a division review and L2 localization. And then we add the batch normalization for this layer. And for the draw up layer, we randomly draw 50% of the neuron during the training. And to prevent the network, this help prevent the overfitting by making the network more robust. And then finally, we have our output layer, which has 10 neurons for 10 CIFAR classes. And then we have our softmax activation, and this will be our model design. And then we combine the model. Then we have our callbacks, which reduce the first callback is to reduce the learning rate when the validation metric stop improving. The second one is to stop the training early to prevent overfitting. And then the next one is to save the model during the training. And then we train our model and we evaluate our model by making the classification report. And then we also make the confusion method with the heat map. And also we plot for we make the bar chart for accuracy for each class. And then we make the plot for accuracy and loss curve during the training. And then finally we test the model by with our neural network by uploading our own images, custom image to test it. Now right now the network is still training. Now that we have finished training our model, we can see our classification report with the 10 classes with precision, recall, F1 score, and the support. And this is the heat map. Heat map using the heat map with the heat map for confusion metric with the class name, and you can see the prediction. And this is the bar chart for accuracy for each class, which class has more accuracy than the other. And this is the accuracy curve and then the loss curve. Now we can test our image to see if the model can predict correctly. And the model classifying the image correctly. And our model accuracy is 85.41%. Thank you for watching.